Hey guys, welcome to Code Decode. Today in this video we are going to cover some very important interview question based on API gateway. So this is based on microservices interview question. Most of the time interview will for sure ask you that have you used any kind of interfacing between your front end and back end microservices. So is there any way of abstraction or a way to actually hide your microservices with your front end technology like Angular or React or anything? So yes, we do have that technology implemented, that is API gateway for us. So today we are going to look upon the API gateway and their important interview questions. We had Eureka server, we had Hystrix, we have all implemented in the previous video. We have implemented most of the things that microservices actually require. So is that not enough? Why do we really need API gateway as an abstraction layer? So there are many reasons to it. So we will understand it with the diagram first and then we will look into the theoretical part for the better understanding. So this is suppose my front end. So front end technology is like Angular or React or anything. Now what we used to have was vaccination center and citizen microservice. We also had a Eureka server. This is for client discovery so that we don't have to remember or hard code any kind of URLs in any of the microservice and we can call them with name. So here you give your name and that name is registered with your Eureka server and it will redirect you to the existing microservice. So we have already seen how to implement this use of this Eureka server everywhere in the previous video. We have also seen fault tolerance. So suppose I am asking you give me all the citizens who is actually registered to my vaccination center. So this is going to call this. If this service is down, then even your vaccination center data, like what is its address, what is the name of that vaccination center, is also not visible to you. So what we implemented to handle this failure or fault tolerance is Hystrix. Now what happens if any of the vaccination center is broken into 2 or 3 more microservices, or citizen is divided into 2 or 3 more microservices because the code base is getting larger? Then front end technology guy has to call all those 2 or 3 another microservices to get all the data to front end. So suppose on the page, on the vaccination center page, I am showcasing hello, your citizen name, then last login. Now suppose we are moving the citizen data and the session data in 2 different microservices. The front end has to change whole code. It has to now call 2 different APIs to just for this much information to showcase on UI. You are actually irritating the client and you are making them see where actually your microservice is present, what actually your microservices contains. So this is not the right way. You should always have some abstraction layer in between. And that particular abstraction layer is API gateway for you. So now front end will have just one contact point rather than these 2. So now front end will just give a call to this API gateway. So suppose our citizen service was on 8081, vaccination was on 8082. Every time front end has to call either 8081 for citizen data, it has to call 8082 for vaccination data. Now it just suppose API gateway is at 8083. For all kind of data, it will just have to call 8083. API gateway will understand the request and will route it on the basis of request to either the vaccination center or the citizens. So this is the beauty of API gateway. This is abstraction layer which is implemented in microservices so that client does not have to get irritated every time to understand which microservice to call, what that microservice actually contains, will that be able to respond with the required data. It is the task of now API gateway to understand the request and respond it back with the required data without front end to know the internals of each microservice implemented by the backend developer. So now this is abstraction layer between front end developer and backend developer. So as discussed, client does not have information about what backend developer is developing and hence its abstraction layer is same as in what we have already covered in Java Oops. Now what is another reason? Now suppose I'm changing something in this vaccination center, I'm dividing in multiple parts. Front end does not have to call 3 different microservices. It just have to give a call to API gateway. It will automatically navigate to the right service aggregate your data and give it back to you. So that is why whenever your microservice change, your front end does not need to change, and hence it is loose coupling now. Another very important reason, this reduces the code redundancy. Now you will ask me how code redundancy is reduced with API gateway. So there were many ways where front end was trying to call your vaccination center service, but it is not authorized to do that. If it is not authorized, it will have to stop. So authorization, authentication, logging, monitoring, all these common functionalities have to be implemented on even vaccination center and on citizen microservice. So what was happening was, this is code redundancy. Now all these things that were implemented on both of them can only be implemented on API gateway, because it is the abstraction layer between. Every request will pass through API gateway, and hence API gateway should be capable enough to authenticate, authorize, log and monitor all your requests and then navigate it to particular microservice internally. And hence this is a very important functionality, that it centralizes the common functionality of authentication, authorization and logging. There is one more very good reason for API gateway to be implemented. That is, now suppose that we have two clients. There is a web client for vaccination, like for the COVID site. We can do the registration for vaccine from COVID site. So it can be a web client, or we can do that with multiple apps. So that is mobile client. It uses both microservices. Now suppose I have done some changes in vaccination microservice and which is not compatible with mobile application. What will happen? Will you stop giving support to mobile clients because the changes are not compatible? The answer is no. Even that can be done with API gateway. So what you can do is, you can create version V1 and V2 for vaccination center service, and web client will keep on using the updated V2 and mobile client will keep on using the old version, so that support is not removed for vaccination center data allocation to the client. That is why API gateway also handles multiple versions of same microservice having compatibility with different clients. So our microservice is updated with new change, but updated service is not compatible with mobile client or application like Covin app or Umang app or many kinds of app which we use. Our client will continue using V1 while other client will move to V2. This can be done using API gateway. Hence, the architecture now contains another layer, that is API gateway. API gateway acts as a proxy that routes the request to appropriate microservice and returns the response to client. Microservice also interact with each other through gateways. This can also be done. I'll be showcasing that during the demo purpose. Now, how API gateway internally works. So I've already told you how it works internally. This was our API gateway. This was our Covin website. This was your Umang application or any kind of application with which you can register yourself to a vaccination center. These are other ways to do the same thing. Now these are multiple clients. All of these requests will go through API gateway. API gateway will internally implement authentication, authorization, logging, monitoring, everything that is needed for your microservices. Now, when it is authenticated, authorized, everything is done, then internally routing is implemented in API gateway, and that routing routes your request to either vaccination center or citizen center service based on your request. So this is how API gateway internally works. It works upon routing principle. I will showcase that to you how routing is done in API gateway in Spring Boot in few seconds. Before that, let's see what are the implementations of this theory of API gateway. So API gateway is a concept with abstraction, which abstracts your front end people with back end people, so that front end does not need to know and everything about each and every microservice that backend people actually implement. What front end needs to know is where your API gateway is present. Hit your request to API gateway. API gateway implements the routing technique, and that routing technique takes you to the required microservice, gives you response and gives it back to front end. Whole theory of API gateway is actually having implementations in different ways. So there are basically 5 or 6 ways where your API gateway is implemented. The very important and very common of them is by Netflix. So the one named as Netflix API Gateway is Zool. Second is Amazon API Gateway. Third is MuleSoft. Fourth is Long API Gateway. And fifth is Azure API Gateway. The sixth one is very important, that is Spring Cloud Gateway. In real world, you will mostly see the projects using Netflix API Gateway or Zool. So whenever you see Zool implemented in your project, that means you are using Netflix API Gateway. But for the demonstration purpose, we are not going to use Zool, and there is a reason why I'm going to use API Gateway from Spring Cloud and not from Netflix. And there are two main reasons. I'll explain both of them now. Now, whenever I talk to you about microservices and their issues, so the issue comes as you need client discovery. So what name comes to your mind was Eureka server. The issue is fallback methods to have failure control, to have resilience. The name comes to you is Hystrix, which is again Netflix OSS. Eureka, again Netflix OSS. When I talk to you about API Gateway, the thing comes to your mind is Zool. That is also OSS of Netflix. So whenever we speak about microservice, the first thing comes to your mind is Netflix OSS. Like Eureka, Zool, Hystrix. But recently we have seen that most of them are in maintenance mode. So when they say they are in maintenance mode, what does that really mean? That means that no new feature are going to be added to these modules. That means this is the end of era of Netflix. That means now they are only going to perform some bug fixing and security issues, nothing else. The only module which is for sure not in maintenance mode right now is Eureka module, and hence we will continue to use Eureka as a client-side server discovery module for us. Now you will ask me if you have covered Hystrix, but Hystrix is now in maintenance mode. So what is the superseded solution to it? The solution to that is Atlas. Similar to that, you have Cloud Netflix Zool, and it is also going in the maintenance mode. So what is the successor or what is the superseded technology for that? The thing is, for that is Spring Cloud Gateway. So this is very big reason that now Netflix era is coming to an end. They are going to maintenance mode. So we are now moving to Spring Cloud technology. So today I'm going to cover the API Gateway with Spring Cloud Gateway. The second reason why I'm not going to use Zool for demonstration purpose is a very big reason. That is, Zool is blocking API. So what does that mean? It is blocking API and Cloud Gateway is not blocking API. The blocking API means it is going to use as many of threads available to handle the incoming request. So let me explain it. So suppose this is my API Gateway Zool, and it is T1, T2, T3, T4 thread available to handle your request. So you request R1, you request R2, good. It will be handled by T1, it will be handled by T2. Even R3 and R4 will also be handled by T3, T4. Now suppose fifth citizen comes to your gateway and says, even I need registration for the vaccination. It says, I only had 4 threads. I cannot entertain you. Go in a queue. Wait there. Whenever I have my thread free, I'll assign it to you. So this is such a bad user experience. This is blocking API. That means only the number of threads available to handle your incoming request will be entertained. Rest all requests will go in a queue and they will have to wait for their vaccination. So this is a blocking API. That means number of threads available are only available to handle incoming request, and hence it is intensive in terms of resource. So if no thread is available to process your incoming request, your request is to wait, which is a very bad user experience. And hence using Spring Cloud Gateway removes this disadvantage, and that is the advantage of Spring Cloud Gateway. It is a non-blocking API. That means that a thread is always available to process your request. These requests are then processed asynchronously in the background, and once it is completed, response is returned. So no incoming request is blocked when you use Spring Cloud Gateway, and hence that is why I focus so much on Spring Cloud technologies rather than Zool. Now how does Spring Cloud Gateway works? So we are going to see this in a demonstration practical way rather than very theoretical one. But you need to tell me in which way do you want me to implement the API gateway. Do you want me to implement it using Spring Cloud Gateway, or do you want me to implement using Zool, which is in maintenance mode? So your inputs is actually important to me. Just let me know in the comment section which one do you want to use. And if you like this video, please support us by liking and sharing and subscribing to our channel. Thank you.